What are factors? Factors are just numbers that multiply to each other to make another number. So let's say we had 2 times 5 equals 10. What are the factors in this equation? Notice how 2 and 5 are two numbers that multiply to each other to make a new number, 10. So that means 2 and 5 are our factors for this equation. What about 3 times 2 equals 6? What are the factors for this equation? Notice how 3 and 2, they're two numbers that multiply to each other to make a new number, 6. So that means 3 and 2 are the factors of this equation. What if we wanted to find the factors of a number without an equation? For example, let's say we wanted to find the factors of 8. How can we find the factors? We need to find two numbers that multiply to each other and equal 8. So let's start with 1. 1 times what is equal to 8? 1 times 8 equals 8, because 1 times anything is just the number itself. This is one pair of factors. By the way, a pair just means two things. For example, when you're outside, you wear a pair of shoes because you wear two shoes. When it's cold, you wear a pair of gloves because you're wearing two gloves. So a factor pair is just two factors. So in this case, our two factors are 1 and 8. But are there any other factors that can multiply to each other to equal 8? Are there any other pairs? Let's take a look at 2. 2 times what equals 8? 2 times 4 equals 8. So 2 and 4 are also a factor pair. Are there any other factor pairs? Let's try 3. 3 times what equals 8? So let's use guess and check. 3 times 1 equals 3, which is less than 8. 3 times 2 equals 6, which is also less than 8. 3 times 3 equals 9, which is larger than 8. This means that 3 isn't a factor of 8, because 3 can't multiply to anything that equals 8. Now what about 4? 4 times what equals 8? 4 times 2 equals 8. But notice how we have 2 times 4 up here. When we're multiplying things, it turns out that it doesn't matter if we switch the order. If we do 2 times 4, it's the same thing as 4 times 2. If we do, for example, 3 times 7, it's the same thing as 7 times 3. Notice that these pairs have the exact same factors. So really, these factor pairs are the exact same. Once the factor pairs begin repeating themselves, then we can stop. We're done. So 8 has two factor pairs. So the factor pairs of 8 are 1 times 8 and 2 times 4. Let's find the factor pairs of 12. Let's start with 1. 1 times 12 is 12, so that's our first pair. Now 2 times what equals 12? 2 times 6 equals 12, so this is our second pair. What about 3? 3 times what equals 12? 3 times 4 equals 12, so this is our third pair. But what about 4? 4 times 3 equals 12. But notice that these factors, they repeat each other. So that means these two factor pairs are the exact same. So this is not a new factor pair. So these are the three factor pairs of 12. So the factor pairs of 12 are 1 times 12, 2 times 6, and 3 times 4. What are prime numbers? Prime numbers are numbers that only have a single factor pair, where the factors are only 1 and itself. So let's take a look at an example. Let's say we wanted to find the factor pairs of 3. One factor pair is 1 times 3, because 1 times anything is just that number itself. Now let's try 2. 2 times what equals 3? Let's guess and check. 2 times 1 equals 2, which is less than 3. 2 times 2 equals 4, which is larger than 3. So we can't multiply 2 by anything to get to 3. So that means 2 is not a factor. Now what about 3? 3 times 1 is 3, but notice how these factors, they're the same. So that means these two factor pairs are the exact same. So this is not a new factor pair. So the only factor pair of 3 is 1 times 3, and that means 3 is a prime number. What about 7? Is 7 a prime number? Let's try to find the factors of 7. 1 times 7 is 1 factor pair of 7. What about 2? Is 2 a factor of 7? Let's guess and check. 2 times 1 just equals 2, which is less than 7. 2 times 2, that equals 4, which is also less than 7. 2 times 3, this equals 6, which is less than 7. 2 times 4, this equals 8, which is larger than 7. Notice how we're not able to multiply 2 by something that makes it equal 7. So that means 2 is not a factor of 7. Nor is 3, nor is 4, nor is 5, and nor is 6. None of these are factors of 7. And if you don't believe me, you can test it for yourself. But what about 7? 7 times 1 is 7. But notice how these factors, they repeat themselves. So that means these two factor pairs are the exact same. So 7's only factor pair is 1 times 7, and that means 7 is a prime number. What about 6? Is 6 a prime number? Let's start with 1. 1 times 6 is 6. But what about 2? 2 times 3 is 6. Notice how 6 has more than 1 factor pair. If a number has more than 1 factor pair, it's not a prime number. So 6 is not a prime number. Now let's talk about prime factorization. Sometimes we might have larger numbers like 18 that can be broken up into multiple factors instead of just 2. What we want to do is break these factors down into prime factors, which are just factors that are prime numbers. Let's start factoring 18. By the way, a prime factor cannot equal 1, so we don't need to write 1 times 18 as a factor pair. So let's start with 2. 2 times what is 18? 2 times 9 is 18. Now, can 2 or 9 be broken up into more factor pairs? Are either 2 or 9 a prime number? Let's start with the left. Is 2 a prime number? It turns out that the only factor pair of 2 is 1 times 2. And recall that any number that only has 1 factor pair, with one factor being the number 1 and the other factor being itself, is a prime number. So that means 2 is a prime number. Now what about 9? Is 9 a prime number? 1 times 9 is a factor pair of 9, but so is 3 times 3. So that means there's more than 1 factor pair for 9, and 9 is not a prime number. Now we need to consider 3 and 3. Is 3 a prime number? 3 only has 1 factor pair, 1 times 3, so that means 3 is a prime number, which means 3 is a prime factor. Since we know this 3 is a prime factor, that means this 3 also has to be a prime factor. So our prime factors are 2, 3, and 3. Now, to check our work, if we do 2 times 3 times 3, if we multiply all 3 prime factors together, it should equal 18, which is the same as the original number. 2 times 3, that equals 6, times 3, this equals 18. So that means these are the 3 prime factors of 18. Now let's try 32. How can we break this up? Recall that we don't need to do 1 times 32 because 1 is not a prime factor. So let's start with 2. 2 times what is 32? Recall that the dividend divided by the divisor equals the quotient, and the quotient times the divisor is the dividend. Notice that the quotient and the divisor are actually factors because they're two numbers that multiply together to form a new number. So let's divide 32 by 2. 2 goes into 3 one time, and now we have to subtract 3 by the divisor times the amount of time it can go in. 2 times 1 is just 2, so we have to subtract this by 2. 3 times 2 is 1, and now we have to drag down the second number. Now how many times does 2 go into 12? 2 goes into 12 6 times. And now we have to subtract this by the divisor times the amount of times it can go in. 2 times 6 equals 12, so we have to subtract this by 12. And now we have 0, so we're done. So 32 divided by 2 is 16. So let's rewrite this like this. Recall that the divisor times the quotient equals the dividend. In this case, 16 is the quotient and 2 is the divisor. Notice how that means we can write 16 here, because 2 times 16, the divisor times the quotient equals the dividend, 32. Now, is 2 a prime number? The only factor pair of 2 is 1 times 2, so that means 2 is a prime number. So 2 is a prime factor, and we're going to leave that alone. Now let's move to the right. Is 16 a prime number? 1 times 16 is a factor pair of 16, but so is 2 times 8. So that means 16 is not a prime number. Now let's go from left to right again. On the left, we know that 2 is already a prime number, so that means this is also a prime number, which means this 2 is also a prime factor. Is 8 a prime number? 1 times 8 is a factor pair of 8, but so is 2 times 4. So that means 8 is not a prime number. On the left, notice that we have 2 again, and 2 is a prime number, so that means 2 is a prime factor. So we're going to leave that alone. On the right, we have 4. Is 4 a prime number? We can break 4 into 1 times 4, but another factor pair is 2 times 2, which means 4 is not a prime number. But notice that both 2's are prime numbers, so that means these are both prime factors. So our prime factors of 32 are 2, 2, 2, 2, and 2. Now let's check our work. 2 times 2 times 2 times 2 times 2 should equal the original number, 32. 2 times 2, that equals 4. 2 times 2, that equals 4. And then times the remaining 2. 4 times 4, that equals 16, times the remaining 2, that equals 32. So that means we have the right solution. An easier way to think about prime factorization is just thinking about how many times you can factor something until you can't. So let's try this method with 32. We can really factor it by any numbers we want. For example, we can start with 4. 4 times what is 32? 4 times 8 is 32. Now, can we break this number into factor pairs? We can break 4 into 2 times 2. Can we break 2 into factors? The only factor pair that we can break 2 into is 1 times 2, which means that 2 is a prime number. And since 2 is a prime number, this is also a prime number. So both of these are prime factors. Now let's take a look at 8. We can break 8 up into 2 times 4. 2 we already know is a prime number, so we're going to leave that alone. 4 can be broken up into 2 times 2. And these are also prime numbers. And notice how we have the same solution even though we started with 4. The goal with prime factorization is just to keep factoring until you can't. Let's try another problem. Let's try 63. Now, what two numbers multiply to 63? 7 times 9 equals 63. Now let's start with the left. Can we factor 7 any further? We can factor it into 1 times 7, but since this is the only factor pair of 7, that means 7 is a prime number. So therefore 7 is a prime factor. Now what about 9? 1 times 9 is a factor pair of 9, but so is 3 times 3. Now can we factor 3? The only factor pair of 3 is 1 times 3, so that means 3 is a prime number. And since we know 3 is a prime number, this 3 also must be a prime number. So this is a prime factor, this is a prime factor, and this is a prime factor. So the prime factors of 63 are 7, 3, and 3. Now let's check our work. Let's multiply the factors together. If we did it right, this should equal 63. 7 times 3, that equals 21. 21 times 3, that equals 63. So therefore, we got the right solution.